Oh, Math 96. So this is going to be notes, page 85, day 2. So if you didn't do day 1, please go back to Google Classroom and do day 1 of the notes. Okay, so we're going to rewrite today from radical notation to exponential and the reverse of that, which is from exponential notation to radical notation, okay? You do have homework tonight. The homework appears at the end of this video. And let's get started. So remember yesterday we were talking about writing as power over root. We're going to finish up your notes on page 85. This is on page 4 of your notebook. And I do want to bring attention today to these columns: the square, the root, the cube, the fourth power, fifth power, and sixth power. So sometimes in our final answer, we're going to have to convert numbers. So if you don't know what 4 to the third is, that it's worth 64, or 3 to the fourth is 81, then you can use this other part of the chart to find out how much those values are. And I'll refer back to this, I think, when we're doing a couple of examples. And then again on that chart, we do the square root, cube root, fourth root, fifth root, and sixth roots. We use this chart. It's on page 4 of your notebook. Okay, we're going to skip example number 8. Excuse me. So the directions say write an equivalent expression, write it in radical notation. So remember, that means that it's going to be power over root, right? Power over root. So let me make this a little bit bigger. There we go. So 1 is going to be the power, and 5 is going to be the root. So we're going to draw our symbol. Fifth root, and then for the first power, we're going to put a 1 here. And then everything that's inside the parentheses goes in here. And then like yesterday, we're going to go ahead and decide who's in and who's out. So we're going to write an empty fifth root, and then we're going to use our chart for fifth root of 32. Right, fifth root of 32 is right here. It's worth 2. So for the fifth root of 32, out is 2. That's because you could break down 32 and 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. There's 5, so out comes 2. Remember, this is how many it takes to get out. So if you have x to the 10th in your head, can you think how many x's get out? I'll draw it for you. There's 5 x's. 9, 10 x's. It's groups of 5 to get out. So out is x. Out is x. 2 x's came out, so I write x squared. These are out. There's none left in because we took care of all 10. And then the y in the back is just a y to the hidden 1, so there's not enough to get out. So we leave y in, and that's our final answer. Now this hidden exponent of 1 that was up here, we didn't need to use that at all because it's just to the first power. Okay, so the next one is power over root. So we're going to draw this. It's to the first power, and it's a square root. And then we're going to put everything in the inside. So then you can go back to your chart if you want. If you don't know what the square root of 64 is, you just look underneath the chart. So square root of 64 is 8, because 64 is 8 times 8. It takes 2 to get out, and I have 10. So hopefully you know that there's 5 sets in the 10. So I have to write them in sets of 2 to get out. And to write 10 of them takes 5 sets. 2, 4, 6, 8, 10. Out is A, 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 and a total of 5 A's came out, so it's A to the 5th. These are all out. And then B to the 6th, I hope you can think that that's 3 sets. 2, 4, 6. Out is B, out is B, out is B. These are all out, so it's B to the 3rd, and there's nothing left inside the radical. Everything came out. Okay, so that's just a bit of review of how to write from an exponent to a radical. Now we're going to do the reverse and finish up the notes. Write an equivalent expression, write it with an exponent. So I'm going to get started with number 11, and then we'll come back to number 10. Number 11 I'm going to start with because you visually see everything. So you should know that this is cubed root. This is to the second power. So we need to write this as an exponent. So our base is x to the what power over root? Power over root. So it's going to be x to the 2/3. Power is 2, root is 3. That's it. Just want you to write it as a fraction exponent. Now I'm going to go over to this one. Well, where are all the numbers, Miss Arthofer? Well, they're all hidden. So this is a square root, and yesterday I really emphasized knowing that if you don't see a number, like here's 5th root, here's 7th root, if you do not see the root, it's a square root, you have to know that it's a hidden 2 and fill that in. And then also, how many m's are there? Just one, so it's to the first power. Okay, so square roots, you have to know to fill in your own too. So there's your power, there's your root. So you write the m to the 1/2, power over root. Power over root. So number 12 is similar. It doesn't show what number is in the root, and you know that it's square root because you've been doing that since you were a little kid. But now you have to fill in the 2. Now, when you have two items like x and y, you have to put those in parentheses because both items are in the square root. So this is the root. This is the power, third power. So this is going to be to the 3/2, power over root. So when you have more than one item, you have to put it in parentheses. So the first thing we're going to do is put this in parentheses. Now, what power is the whole original thing to? What's the power on this? It's a hidden 1. See on this one, if it's not a hidden 1, how they put in a 3 over here? So this is where the idea of the adding parentheses and things being hidden is important for me to show you for when you move on to college. When I give you a problem, I don't give you the hidden ones. I give you ones more like this on number 14, okay? But I still want to show you that this is to the first power over 5th root. All right? Just so you get reinforced about hidden things in mathematics. Okay, so we're going to take the inside stuff and we're going to put it in parentheses, power over root. The outside number 3/7. And that's it. That's all you have to do. That's it. If we want you to take it from a radical to write it with an exponent, that's it. You don't have to make it any harder than that. It's the final answer. Okay, so this is your homework. I want to do a couple of them with you. So let's go over to this side right here where it's 36 to 46. And let me do one with you. So let's do number 40. So remember, if you don't see any number inside your root, it's a square root. And so this would be a to the 3/2, power over square root. Okay? So for this one, I hope you know where to fill in the hidden 1 and the hidden 2. On number 36, what 10 to the what power? What's the power there? It's a hidden 1. Okay? So I'll help you out with that one. That's a hidden 1. All right? So we'll see what you can do with that one. So if this one, it's 10 to the first, then that'll be 10 to the 1/4. Power, first power, over 4th root. And why is 10 to the first power? Well, if it wasn't 10 to the first power, if it was like to the third power, we would fill it in. The only one that's hidden there is a 1, okay? All right, you should be able to do the rest of those. I want to go over to 16 to 32 and just do a couple of those with you. Now, in this direction, it says write an equivalent into radicals. So let me do number 18 with you, and you can do the other ones here. So power over root. So this is fourth root of 81 to the first power. Now you have to go ahead, simplify if possible. So you have to ask yourself, can you reduce the fourth root of 81? Well, if it's on this chart, it needs to be reduced. So fourth root of 81 right here, you need, since it's on your chart, you need to do it, okay? So that's why I filled in these spots with diagonal lines, because I didn't want you to think you had to do all of them, because obviously it could keep going, right? You could do the fourth root of the next number. So if it's on this chart, you need to convert it. So where's my homework? So fourth root of 81 simplifies to 3. So you'll be able to simplify 16 and 20. All right, let me show you another one. So number 22 says to write it as a radical. So it's to the first power, fourth root of AB. Can you do anything with that? Can you do the fourth root of A or B? Is there enough for something to get out? Nope. So that's it. That's the answer. Now, should you write it with that hidden 1 in college? No. I don't mind if you write it like that, because the hidden 1 up there doesn't do anything to the value of your problem. So this is more appropriate, fourth root of AB. Okay, now let me show you one where you go ahead and you do some conversion. Number 28. So this says square root of 4 to the 7th. So I want you to write it with parentheses, because you have to check and see if you can do the inside. Can you do the inside of square root of 4? If it's on this chart on page 4 of your notebook, if it's a square root and it's on your chart, and I know your chart goes to the square root, I forget what it is. Is it 225? I think it goes up to 15. If it's on this chart, then you have to convert it. So square root of 4 is 2. So I'm going to do the inside first. Square root of 4 is 2. And then I'm going to bring down that 7. So now I'm at 2 to the 7th. Now the question is, should I keep going, Miss Artofer, and figure out what 2 to the 7th is worth? Well, go back to your chart. Do I have anything in here? Now we're going to use the other part of the chart. So look at, let me make this bigger. We're going to use the other part of the chart. So you're looking in these numbers: squares, cubes, fourths, fifths, sixths. I don't even give you sevenths. I give you 2 to the 6th, I give you 2 to the 5th, 2 to the 4th, 2 to the 3rd, 2 squared, but I don't give you 2 to the 7th. So my stopping point is 2 to the 6th. I have to give you a stopping point. Otherwise, you wouldn't know where to stop. 2 to the 7th is not hard to figure out. It's 2 times 2 times 2 times 2 times 2 times 2 times 2. It's actually 132, or no, 128. But you don't have to do it, okay? Because it's not on the chart. Sorry, I went to the wrong page. So 2 to the 7th is just fine as an answer. So let's find another one where I can show you. Do I keep going, Miss Artofer, or not? So let's do this one, and then you're going to try the rest, okay? So we're going to write this in the radical form. Put parentheses. Power over root, so cubed root to second power. I'm going to go ahead and take a picture of that really quick, just so I can I have a little more room to do the problem. This is easier for me. Okay, let me just redo it real fast, you guys. Okay, so 125a to the cubed root, and then use parentheses to the second power. Then focus in the inside and bring down the outside power, okay? So can you do cubed root 125? Yes, you can. It's on your chart, and you have to know that. Cubed root of 125 is worth 5. Okay, so you got to get used to the numbers that you can do. So out comes 5. And then what about cubed root of a? You can't do that. Oops. And then we bring down the square. Okay. And that's all you have to do. Okay, so we're going to go ahead and give these problems a try. I can finish this one up for you here. So on this one, out came the 5, in stays the a, and we keep the 2. All right, and you don't do anything more with that outside 2 on this one. All righty, give this a try. I will see you tomorrow. Have a great day.